All right, my friends, let's get rolling. This lighting, not great. I don't like the front like that. Y'all good in the back? You want, I can't give you more light. Would you like less light? You're good. It's a little intense. Gentlify it 10%. All right, friends, so week 2, crazy, here we are. Stuff to request, if you could please, for Wednesday, check out these sections. And so I say read, watch, whatever. They have, there's nice videos that you can watch in the textbook. And if you're finding any of this challenging, or you're kind of like, it's been a while, if last class you were kind of like, it's been a really long while, then you can prep ahead of class. At some point, these resources are always there for you, the videos you need. And if you like to read, then the book is pretty well written, straight to the point. I think it's great. Reminders, please bring your laptops. So I don't have to do printouts of the problems when we work through them. Everybody scored on that one. And by the way, you all made me so happy. So one of my great stresses, especially coming into business calc, is that I'd have to like herd cats. You know what I mean by that? You ever try to herd cats? It's crazy. So like the business, when I've taught this class in the past, it's been stressful for me because the business folk didn't seem to be doing business well. Like not showing up on time. Hello, 2 more folks. And just not doing things that I asked that were very simple. Everyone, I went in to check this morning, I was dreading going to see who had registered for my open math, and it was everyone. And it just started my day off so well. So thank you. You're all absolutely on the road to success. And that's what we hope to achieve here. Homework 1, 2, and 1, 3, those are due Sunday. I'll see if there's any questions about 1, 1. We'll take some time to work on this stuff today. We'll take some time every day to work on stuff together so that you have support when you need, and just, well, you have support. Homework 1, 4, I would kind of like to not lecture about because it's a review of exponent laws. So what I wanted to try is to give you this and say, could you please just watch those videos? And then we'll talk about it in class if there's any problems, and I'll give you a homework on that section. It's a really short section, really short. And it's just the basics of exponents. Does this sound okay? Is anyone, yeah? Okay, cool. And like, I guess no one's gonna like rebel and say no, but let me know if you need anything. So let's start off first with coming into our room. And like I said, we're gonna do this every day. So I ask that you please just, if you have a laptop, you all have laptops because I asked you to, let's just close those for a second so we can let go of the things we have to do, of doing things. And just sit for a second. And each day I'll maybe give a different pointer, and you can take it or leave it as you see fit. But today, what I would ask is if you just close your eyes and notice what your body feels like. The simplest thing in the world, in a way. And so this is a little different than you might think it is. I'm not asking what you remember your mental image of your body to be. If you just woke up, all of a sudden you're conscious, your eyes are closed, that's all you can see. What would you think your body looked like based on pure sensation? So coming at this as a scientist, and maybe as a baby, as you notice the feelings, shape does your body feel like? Just breathing normally, nothing fancy here. Find yourself drifting into thoughts of what happened this morning or what will happen next, very gently and lovingly return back to just noticing your body feelings. Same gentleness, let's just come back. Howdy, Mace. Glad you're here.
Sorry, I was late.
It's okay, I'm glad you're here. We have 6 in the class. 6 people, damn. 20% increase, incredible. All right, so today I've got a list of things. What was on my list of things? I wanted to talk a little bit about interval notation. We started that last time, we didn't get really far. I wanted to review it a little bit more in a deeper level. It's not on your homework. So one of the things I wanted to point out to you in this class is you will know exactly what this class requires by looking at the homework. What will be on the next exam? Oh, yes, perfect attendance. We have everybody here. Hello. Hi. I'm glad you're here. 7, unbelievable. The 8 of us are here. What a day. What a day.
Truly remarkable.
It truly is. Yeah. That's a hell of a good way to start the second week. So I want to review interval notation, but you won't find any of that on your homework. We're going to just lay the seeds, and then we'll come back to it later on. I want to talk a little bit more about functions, a lot more about functions. And first I wanted to see if there's any questions that y'all have about that homework 1-1, and my friends who are joining us today. Have either of you had any trouble getting into the homework or checked it out yet? No?
No, no trouble.
Beautiful, beautiful. Does anyone want to talk about homework 1-1 or anything there that's vexing? I think it's due tomorrow. We're good?
Oh,
Yeah, cool. Fan-freaking-tastic. Let's review some interval notation. I'll leave this up. Cool. And as I said, you won't need this immediately, but we will need it significantly when we start doing the calculus portion of the class. Let's look at a number line. So this represents all the real numbers. You pick a spot to be your point of reference, your original point. It doesn't always have to be 0, but I'm going to make it 0. And then here we have the positives, and then here we have the negatives. And we always work left to right because our whole society is built around the biases of the people who built the system. Although it does seem like we should go right to left with all the right-handers. So I don't quite know, but what's that?
I disagree as a left-hander.
Yeah, you what?
I disagree as a left-hander.
You're a left-hander.
Yeah, but I throw it. It's super weird. I only write with my left hand.
Oh wow! And you still write with it broken?
Yeah.
Is that taxing?
Not really.
You figured it out.
Yeah, I just put it together, I guess.
Nice. Are you an athlete?
I was. I played lacrosse for 12 years, and then I tore my ACL.
Oh God, yeah. you're gonna get injured in lacrosse. Yeah. Yep, I'm sorry to hear that, miss.
Oh, dude.
So we're always gonna work left to right as we're reading off things on this line. What do I mean by that? Well, let's say I have the number line and I mark off something like this. I want to show you a couple bits of notation. So right there, I'm setting a point of reference to, and then I've also let the person who's looking at this understand what 3 is on this line, right? This could even be 50. And then I've told that person what 48 is on this line. So we just set 2 points and we've determined everything a person might need to know. What do these parentheses mean here? Can someone help us out? What does that mean to write parentheses like that?
It means that number's not included.
Not included. So when I use these open-ended things, and what I'm really trying to describe here is everything between 2 and 5, not including the points. So this means don't include this point. If I were going to write this, and this is very suggestive because I want to translate that into an interval notation. And the way I would do that is starting at the left, I write 2, I'm not including the 2, and then I put a comma 5 and not including the 5. This means everything between 2 and 5, not including the endpoints. I could also use this type of sketch to represent the same thing. I could put 2 and 5, and I put open circles on those. That's a completely legitimate way to do this as well. Just color in the middle, like so. It's familiar. This all sounded, yeah, cool. Always let me know if there's a problem. We'll talk about it. And we're gonna work today on stuff. So I'm just gonna lecture for a little bit. That's my goal anyway. What does this mean? Let's say you have 2, 5. What does it mean if I put closed dots on there? Inclusion. Oh man, that's a lovely sophisticated word. Inclusion. I'm including those endpoints. So this means point is included. The interval notation for that would be a closed bracket. So everything from 2 to 5. And if I wanted to, I could use these brackets on the number line as well. So I'm kind of going backwards from the flow that I had here. So, or I could have 2, 5, and just color that all in. It's all good. Honestly, you choose what you want, whatever feels good. If you have to do this for me at any point, eventually you will. You can also have combinations of these things. So if I asked you to describe this number range, so let's do 2 to 5. I'm really getting some work out on this 2 to 5. If I put an open circle here and a closed circle here, can you just take a second, just write down what is that in interval notation? Using this type of notation. And then if someone could help me out, that would be just, I like the word dank came to mind, but this isn't quite dank. It'd be sweet.
It'd be parentheses 2, comma, 5 bracket.
I love it. Is that sounding good? Yeah, cool. I didn't see Caroline, you cool in that? Yeah, sorry, you were eclipsed by Jeff. So, so let's get this a little fancier. Let's introduce a new symbol or remind ourselves of a new symbol. What's that symbol stand for in math? What's that, Lorelai?
is it union?
Yeah, I saw your mouth like saying you. Yeah, exactly. So union. So this equals the symbol for union, and it's really union of sets, and a set is just a collection of numbers for us. It can be lots of things if we get fancier, but for a while it's just a collection of numbers. This is to join, so this is used to join intervals for us. That would be our prime use for it. So let me give you an example of what I mean. Let's say I have the set, and I'm going to go back to freaking 2, but now I've got a 2 with a closed dot, and I'm not coloring in this section, and I'm going to go up to 3. I'm going to put an open dot on 3. I'm going to go to 5. So I'm going to go a little bit further, put a closed dot on 5. So I'm definitely intending that to be thicker between 3 and 5 than that section. And then let me go one more up here. Let's hit 6, put a closed bracket there, go to 7, closed bracket. So union allows me to link together intervals. And remember, always working from left to right. I guess the left to right makes sense. That's the order of increasing things. So we always want a lesser number on the left and a greater number on the right. So could you take a second, take a stab, and just see what you remember? I won't know. Can you write this out using a symbol? How do you write just a point? Any ideas? Yeah, Jack.
Just the number, if it's included in 2 brackets.
Cool. Yes, so pretty close, and we do want to make it look like a little set, so we add these braces. So for single numbers, just put them in braces, or if you see that, that's what that means. So let me get you started. What are the 3 different things we're unioning? 1, 2, and 3. Let me get you started on the next part. Katya.
Yeah.
Okay, thank you. So sorry. Got it now. Just making sure I know everybody. Thanks, Katya. And thanks for doing all that stuff. So one thing one way I like to think about this is it allows me to skip over sections of the number line. It almost looks like skipping rope in some ways, if that's something, I guess people still do that. So I start at the 2, I skip over all this stuff, and the next thing I pick up is the 3, which has an open end. I go up to the 5, I close that off. Now I've got to skip over everything between 5 and 6, and I pick it up at 6 to 7. And that's pretty much the end of the review. That's all we need to be able to do. Yeah, Mason.
In terms of like how you wrote out 2, like comparison to 6 and 7, because there's no line connecting 6 and 7, how come you?
I did intend for there to be some. Yeah,
Oh,
sorry, that's not obvious.
No,
yeah.
I was just confused because the 2 or 6 and 7 became its own set.
You're right. So if that had not been connected, so that's a great addition to this. If I hadn't intended that to be an interval, and just so you can check yourself, I would have done this. Does that make sense?
Yeah.
Awesome. Any other questions or troubles? Cool. All righty, so let's talk a little bit more about functions. And Katya, I made a call for questions on that first homework. Do you have any? Are you good?
No.
Fantastic. Beautiful. So today, in terms of functions, first thing I want to talk about is composition. And this, besides knowing what a function is, this will be the most important thing for calculus. This idea right here is the one that people have trouble with. And they think it's something other than what it is. So let's spend some time talking about composition of functions. So remember, a function's a rule for turning one collection of numbers into another set. So we have some function f. So here's a set of numbers. Let's just draw a little, make this very vague and hopefully not just too weird. But I have a function that takes those and it spits out, takes each one of these, does something to it, and spits out a new set. In fact, we could think this is the domain of functions. This is everything I'm allowed to feed into the function. Let's call that f. And over here I have the range, which is also a set of numbers. Probably different than this first set. Now, let's say I've got another function that eats these numbers. These are the valid inputs for another function. So let's say I've got this function g. So let's be a little bit more precise here. This is the domain of the function f. This is the range of the function f, but it's also the domain of the function g. So these are inputs for g. These are inputs for f. These also tend to be the outputs for that rule. And I'm going to make this really abstract, and then we'll get into the nitty-gritty, and it'll probably come together. And then finally here, I just have the range of g composed. Oh my God, I'm writing so tiny. G composed with f. It might not be everything that G could normally hit, but it is this followed by this, and composition is just a chain of functions. So let me make that a little bit more precise. What do I mean? What? So G composed with F means first find given input x, first find f of x. Then take that is just a number, plug that into G. Then plug that f of x into G and get G of f of x. Notice how I read that? G of f of x. So in this class, when you hear the of, or you say the of to yourself, it's composition. You can think of that as a function. Definitely the word of comes only in the case of functions for us. So that's the general theory. Let me give you more precise examples. Let's do a bunch of examples. So first off, let's say that I have a function f. It takes its input, multiplies it by 3, takes that result and subtracts 5. And I've got another function, g of x, and it takes its inputs and squares them. So let's draw that picture again. Just like that. I don't know, I just like those pictures. Maybe you freaking hate them. I'm sorry if you do. So we take an x and we run it through f, and it spits out 3x minus 5. Now I'm going to take that, well, here I'm going to find g of f of x. And that means I'm going to take x first, plug it into f, and then take that result and plug it into g. So take this then and run that through g. And what I'm going to get here is g of 3x minus 5. And that g says take whatever inside here and square it. I'm going to actually write this just in a new way next. So if I first use f, apply f, and then I apply g, the result is 3x minus 5 squared. A really cool way and a useful way to think about functions in this class is like this. Think of f as a rule for taking something. Sometimes these just single variables screw our minds up for deeper concepts. Take whatever's inside there, multiply it by 3 and subtract off 5. This rule, g, says take whatever's inside here and square it. And the key to remember is work inside out. Inside to outside. So if I compose in this order, and by the way, the notation for this is g little open circle of f of x. It's kind of like we created a new function. This is g composed with f. Now, I highly recommend please watch the videos in the book on this to just strengthen all of your understanding about this. This will be kind of a make or break idea for the class. So understanding composition is utterly essential. G composed with f of x. So let me ask you this. What if I had f composed with g of x? Now watch how I unravel this. This says first do g of x and then apply f. It's like this, then like this. Almost kind of working left to right in some ways. Or excuse me, I guess not really at all. Think of things as eating. F eats x, g eats that result. So here, fog, which means f composed with g of x, is this. What would that look like? So take a second and write that formula, please. Oh my gosh, I'm so happy to be here with all of you. I really am. Yeah, it's great. I was a little bit dreading doing business calc. Because I've had some hassles in the past. Like I told you, I've had a lot of business majors who just didn't seem like they were very good at business, like legitimate business. I had a student a couple years ago. His business was growing mushrooms in his dorm room.
Solid business.
It's solid, except doing it in your dorm room.
Yeah,
that was the part that got him booted from Regis. So it's like, I really loved the guy.
Actually, I feel like I know who you're talking about.
I think you might. Yeah, he was also mining crypto in his dorm room.
Definitely know who you're talking about.
You know what I'm talking about. He was a great guy. I loved him.
He's a cool dude.
Very cool dude. But we won't mention his name.
Okay.
But I miss him. But that was a bad business decision.
Yeah.
Right? This is kind of like, it's the subtle things in life. Like, don't commit felonies in your dorm room. So let's go through this together. I probably distracted you with all my illicit shroom business talk. I'm going to show you a couple ways to do this. I want to show you two routes to this. So the first route, and you get to the same place, is replace g of x with its formula. So g of x is just x squared. So this means take f. So now look, x squared's inside there. So I just replace every occurrence with that, and I work it through. So this says take whatever's inside here, multiply it by 3, and subtract 5. And so that's one way to do this. The second way to do this is to kind of hold off on this G. So, or, here's what's in the box. The symbol, it's just symbols. So replace that box with G of X, and what you get is 3 G of X. I'm writing the box just to emphasize it, minus 5. So that's 3, I'm gonna simplify it here. G of X minus 5, then replace G of X with its formula, which is just X squared. We get that result. Is this sounding cool? And just let me know. Sometimes you look around, you see people, everybody's nodding their heads, so you're like, well, I guess I'm the only one who doesn't get it. Doubt it. I mean, I know what I do in meetings when I don't care what's going on. You just listen to the person and you're like, yep, not even listening. So we're cool on that? Let's try an example together. Let me give you one. Let's spice things up. So I'm gonna use a different name. So I've got a function h of x, and it's 1 over x. It's the reciprocal of the input. And then we're gonna let g of x equal 1 over x plus 2. Oh, I'm being a bastard this morning. Well, this is a good coffee this morning. Got me really worked up to come in here and harass you like this. Could you please find these formulas? And if you get done early, give it a little simplify. Like, honestly, simplify as much as possible. Oh, hog. Cool. And go. Gah. Can we find those, friends? Please. Sorry, is this your major? You find that's good?
No, it's just another class. It's separated from my class.
Didn't mean to
No,
distract
no,
you from your
you're good.
business at hand. Just to get you rolling, first step is to rewrite it. And then that starts to unravel. Did you get them simplified? Yeah. So this is beautiful. That simplification, not so
Oh, that led me to that.
Oh,
Sorry,
how did you?
backwards.
Oh,
I
okay.
just-
Oh,
that was
gotcha.
sorry.
So
This
let's,
is the-
yeah. So just from my, from my
sorry.
emotional health, if I saw this, I would think, what?
Yeah.
Did she think that's that? So just be careful with
Yeah.
the equals. That's
Yeah.
all. Maybe use an arrow.
Yeah, I probably normally
Okay.
Sorry,
Cool.
sorry.
Cool. Did you do
But
both?
that was very
Did you do both directions?
What?
So you found.
Oh, yeah, no, I did.
Okay. Cool.
What is that one?
Okay, so let's take it. I love that one. How'd you get there?
I just put the X up here.
Because I love this first part.
Yeah.
I don't love that
Okay.
simplification. Check
Yeah.
that out.
Okay.
How we doing?
Not great.
Okay, all right, friend. Yeah, let's work together. Is it okay? I'm sorry.
Yeah,
I didn't
no,
mean
go
to
ahead.
touch your stuff.
No.
So first step to find this is just this means this, so you can just like automatically
Mhm.
rewrite that. So let's replace the g of x with the 1 over x plus 2.
Okay.
So let's go ahead, so write equals h of, and put a little, the parenthesis, put a parenthesis, so the of is the parenthesis, 1 over x plus 2. Nice. Now, may I use your pencil really quick? So let's think, this rule says whatever's inside here, I'm gonna just put it underneath 1. So my next step would be to write, so let's write this together.
Okay.
equals 1 over,
No, that equals.
yep, another equals, perfect, equals 1 over, and then this whole thing, so underneath is gonna be a whole fraction. It's just
Okay.
gonna be the 1 over x plus 2 underneath. Beautiful, yeah, just like that.
Okay.
Now from here, we gotta do a little algebra to simplify, but that's right.
Okay.
That's a great answer. Can you try that? Give that one a shot, and then try it that same way. How are we doing, Katya? Okay, cool. Let's take it. That's beautiful. That's beautiful. And they're both beautiful. Now you got some algebra, but they're like totally correct.
I just have to simplify these two.
Beautiful. Yeah. Yep.
Cool.
Algebra time.
Thank you.
How are we doing, Grace?
Not sure, but possibly right.
Okay, so how did you get this one? Can you walk me through?
Yeah, so I was just taking like the idea of that we just brought it over and down, so I can stack the x's to make it x squared.
Stack the x's. Tell me about what that means.
It's a great question.
It is. It's a new
great
new
question.
math word for me.
Yeah.
So look, man, absolutely real quick. Let's take a look at this one first. So this means first do g of x. That's this.
Yeah.
So think of this as whatever. Oh shoot. Sorry. So whatever's inside here, I just put it down here. Here it happens to just be x. So this is going to equal h of, and let's do g of x first. It just turns x into this.
Okay.
You sure?
I think so, yeah.
So the formula, because this is just shorthand for
So
that formula.
Okay, so it's just plugging that
Mhm.
into here essentially.
Yeah,
Okay.
yeah, exactly. Now h says take whatever is in here and put it under 1. So right now, what's in there is that whole big mess. So I'm gonna rewrite this as 1 over that whole big mess, which is actually 1 over x plus 2 again.
Okay. Cool. Okay.
Does
That
that
makes
sound-
sense.
yeah,
I just
yeah.
didn't know if that was like to go over.
Yeah, and I think you actually rocked this one. But maybe think it through again, because I'm wondering if you're making up some mace math.
Mace math, yeah, for sure.
Jack, you're rocking this.
Is that better?
No.
Okay.
Keep going. This one's beauty. I
Yeah.
love that one. Still not.
Okay.
Tell me what your thinking is on how to do that.
I would think multiply.
So
Oh.
There you go. You missed. You lost an X off the 2 gets an X too. Hi. You going over here?
I don't know.
Okay, this is gorgeous.
Okay.
Yeah, no, it's so friendly. It's just algebra. Got the step 1.
Okay, good.
Step 2, and I made this double fractiony just to be,
It's my
you know,
second one.
oh, that's lovely.
Okay.
That's lovely. I think we should practice some of this today, especially fractions. Yeah, we're going to practice some of this today. All right. Okay, let's go through this together. And everybody's got the step 1, so good work on that. We're all there. It was the algebra that snagged some of us. So 2 different routes. H is a function that takes whatever's inside here and puts it under 1. Just follow the rhythms. If you think less and follow the rhythms, you might be better off. So don't try to do math between here. 1 step at a time is going to save you. So this is h of, well, actually, I'm going to do it this way, because I don't think anybody did. H takes whatever's inside here and puts it under 1. Now we know that that triangle isn't there, so it's just 1 over this thing inside here. And the thing inside here is that fraction. I want to keep it together, use lots of parentheses to save your brain. And I got that. So literally plugging this collection of symbols in the bottom of this. And then it's time to simplify. So I've got a fraction within fractions, but a simpler way to think of this is the reciprocal of x plus 2. So it's just x plus 2. Let's do it a different way. Got a fraction, that's kind of a fraction, but we have a fraction in the bottom. I'm gonna just multiply the top and bottom by x plus 2. As long as you do the same thing on top and bottom, everything stays happy and balanced. So on top, I've got x plus 2. On the bottom, I've got that times that, and they cancel. And I've got over 1. And so I could just more elegantly just write that. Yeah, cool. Let's get to the one that was really causing some fun. Makes you cool on that? Yep. Okay, awesome. So down here, this one is g of h of x. Notice how I'm reading that. I read that as of. Here's what people screw up. They think it's multiplication in their brain. It's not times, and that is the major flaw that most students have. Even my Calc students, Calc 3 students, hell, even sometimes up into my 400 level math classes, I got people thinking weird shit like that. So this is of, it's eating. G eats H. So what does it mean? Well, G, when it eats something, whatever's inside here, it adds 2 to it and then puts it under 1. So right now I've got that box there, and so this is 1 over whatever's in that box plus 2. Happens to be just that collection of symbols. So notice how I'm just following the rhythm set up, and I'm not really thinking here, plugging in boxes, and I just need to understand what are the boxes. And then my last step is to replace h of x with what it represents. This is just shorthand for 1 over x. So I'm going to replace h of x with 1 over x, and I have plus 2. And everybody got to this point, and everybody got to this point, and that's awesome. And there is nothing wrong with those answers. They can just get prettier. So, Jack, you worked this through here. Can you tell me how to simplify this fraction?
Yeah, I just multiply top and bottom by x.
Yes, absolutely. So, I'm looking at all the fractions in here. There's only one subfraction, it's 1 over x. And to clear that out, I just multiply the top and the bottom straight across by x. So the top becomes 1 times x, which is x. The bottom becomes, and this is in parentheses here, x times 1 over x plus 2 times x. And that's the part that was snagging lots of folks. So, awesome answer, better answer. Let me ask a slightly challenging question here. We haven't really talked about it, but we know how to, we talked about it roughly. So I would like to ask you, what is the natural domain of this function? Well, let me explain what I mean. What is the natural domain of x plus 2, that expression? So what I mean is, are there numbers that I can't add 2 to? Are there numbers that I can't replace x with? Because it'll blow up. I'll divide by 0 and Jack's fervently shaking his head in a certain way. I won't respond. Can you think of a number that you can't legitimately add 2 to? Where does trouble come in math? What are some of the trouble spots that we have to keep an eye out for? Divisions, 1. What do I have to worry I'm dividing by?
0.
0. We don't want to divide by 0. What about square roots? So that's bad. We don't do that. What about square roots? What has to be underneath here? Do you remember?
It just can't be a negative.
Can't be a negative. So I'll put a negative under here, and that's bad, but everything else is okay. So these are honestly the two areas to keep an eye out for. When I ask a question, what is the natural domain? What is the legit set of numbers I can plug in here? So this one here is all numbers, all real numbers. Because there's no division and there's no square roots. Because no division, so that could create a trouble, and no square root. Now this seems to be a whole different ball of wax here. So let's take a look at this one. What would be bad here? What would be bad so I'm looking at all the numbers x, so I can let x be 1. If I want x is 1, let's make a little table. If I let x be 1, then the output is 1 over 1 plus 2. It's a third. What would be a bad number to stick in there for x? Is it okay to put x equals 0 in? Let's just work it through in your head. What do you get on top? You get a 0. On the bottom, we get 1 plus 2 times 0. Because I heard someone kind of whisper 0. I heard a 0 whispered in the wind. And so that's 0 over 1. And what is that?
0.
0, beautiful, solid. So I can plug in 0. What I want to make sure is I don't want this bottom to be 0. So let me just put a little note here. Can't have 1 plus 2x equals 0. I can't have that because then I'm dividing by 0. What value of x would make that happen? So solve this equation. Can you take a minute and just solve that for me? You can maybe do it in your head, but you might want to write. I'm going to let Jack take a break for a little bit. He's been doing a lot of lifting for us this morning. Can someone help me, walk me through how to find the x that makes that true? Well, I'll get out my lounger. I'll get my tea. I'm happy to wait.
Negative a half.
Oh, thank you. That's lovely. How'd you get that?
I subtracted 1 and then divided by 2.
Perfect. So first thing, subtract 1 from each side, and then divide by 2. Thank you. Very nice. So x equals negative 1/2 is something we can't have. So let's dock here. So the domain of x over 1 plus 2x is all numbers except that one. Because that gives division by 0. And that's bad. Let's draw a picture. Let's draw a picture of the domain. So everything is cool on this line except that one point. And so I'm just going to mark it off. There's negative a half. I'm going to remove it with an open circle. That says don't use that. And then I'm going to color in these arrows on both sides, and I'm going to get super lazy and shorten my arrows because I don't feel like coloring that whole thing. And then all this stuff is cool. That's all kosher. So this thing here, all numbers except negative 1/2, has a picture form like that. Can you write that in interval notation for me? Starting at the left, what's the leftmost number in the world?
Negative infinity.
Yeah, I thought I saw Katya. I thought you said infinity. I saw it. It's a negative infinity. So we're going to start in interval notation at negative infinity. Go up, skip, pick it up on the right side. take a second on that. Good, I don't need my lounger. Won't find any of this in the homework yet. I'm just working out. That's lovely. That's beautiful. Just walking around. Oh, you're great. You're great. You're great. So, we're going to start at negative infinity. We're going to work. We have to stop at negative a half.
Okay.
So put negative a half there instead of infinity.
Oh, okay.
Yeah. And then a U, the union sign, and then pick it up on the other side at negative a half again.
Okay.
Does that make
And
sense?
then- yeah.
Beautiful.
Okay.
Yeah, perfect. Looking good. Oh, there. Oh, lovely. Lovely. We start where no one can start, at the leftmostest thing in the world. Negative infinity. We go up to negative a half, and we stop there because we can't get to negative a half. So I put an open parenthesis. I skip over the half, the negative 1/2. So this just basically says skip over negative 1/2. And then pick it up on the other side. And then keep on cruising all the way out. So you kind of think there's infinity and there's negative infinity in your mind when you make those intervals up for yourself. Cool. I didn't know we were gonna do that today. It just kind of happened. Sometimes stuff just happens in my class, but it's like relevant, right? This will pay off. We work out, I get a different set of weights off the rack for us than we planned on. So let me, let's try this whole composition thing in a slightly different way. We've kind of got enough there to do some of the homework. But let's look at this, differently. Hey, friends, let's see, I might be able to give you a table today still. So let's see, because I did print some stuff up for you here, so we may not have enough. We might have to share. Would that be okay?
Yeah.
And you can share with you.
Okay.
And could you two share? Would that be cool? Maybe not. Let's see. Yes, I need you two to share, please. Thank you, Brent. Cool. So what I would like us to do is take a look at can you do problems 5 through 8 on that page using that table? I didn't talk about that, but let's see what we can do. Feel free, oh, that's smart. Taking pictures, nice. Give it a shot and see what you can come up with, thinking of the ideas. And then we'll come together and see how that all goes. Remember, work inside out for these compositions. Find the inside thing first, then plug that result to the outermost thing. Pretty fast at this stuff, Jack, so we'll have to come up with some problems to tax you.
Yeah. Get back to it.
Jack, you gave him too much too early.
You did, man. You showed your hand. If you want, Jack, I can see I can keep you slightly busy. You can work on the homework too if you want.
Yeah, that's what I've been
Okay,
doing,
awesome,
starting off.
awesome. Yeah, please do that. I got my friend Mace here. How's it going?
You good, got him.
Think you got it? Sweet. So let's see. So how'd you do this one? Can you walk me through that?
I just kind of took this, plugged that into this.
Okay, so it says take 8 and feed that to G. So when you feed 8 into G, what do you get? Yeah. So let's walk that through together.
So if you put this,
So it's f of 4. So let's write each step of the way. So G of 8 is 4. So this G of 8 just represents 4. So let's write f of 4. You see what I'm saying? And let's use that notation to help us just remember what we've done. Yeah, nice. Now what's f of 4? F of 4. There you go. 4 is actually our answer. Yeah, does that make sense? Try to check those out. How you doing?
Pretty good, I think.
Yeah, I don't even know what the answers to those last ones are, but sure, number 1 is A-okay. So yeah, we'll do them all
Thank you.
together. How we doing, Katya? Oh, beautiful. Yeah, it's looking, at least the first one's looking great. And I think that your answers match Lorelai's. How we doing?
Probably not.
Okay, cool. So, your notation is, you did notice you didn't quite exactly write what they have, and I think it's throwing you off. So it's, notice how there's 2 left parentheses, so it's f of G
Oh.
of, and let's, so just, get rid of that guy. Okay, cool.
Okay.
So what this means, Caroline, is feed the 8 into the G first. So the first thing we want to do is figure out if x is an 8, what is G? So this G of 8 is 4.
Okay.
So let's write next, so equals f of 4. So f parenthesis 4. Yeah! So see how, the first thing I'm doing is figuring out what does G do to 8? And we go to the table. Now, what does f do to 4? So let's use the f column.
Okay.
There you go. Yeah, yes. So that's the final output.
So then I use that.
Oh no, that's the G. So
Okay.
now, see, G's all gone.
Okay.
We did the G stuff.
Mhm.
So now we're just figuring out what, if I put a 4 into F, what do I get out?
Okay.
And you get out a what? Solid.
Okay.
Let's do this next one together.
So like, I'm just looking there.
Mm-hmm.
So does it go like that?
No, so you're done. So
Oh.
F of
Oh.
4
Okay.
is 4.
Okay.
Yeah. So put equals 4 here. Just equals 4. Let's do the next one together. So what is the next one? It's G, F of G of 5. So first off, what's G of 5?
So like there.
So that's the G column, yeah. And so if you put in a 5, what do you get out? Look at, here's your input.
Oh, so you think,
Yeah, yes,
okay.
yes. So this is f of 8.
Mm-hmm.
And now what's f of 8? If your input on f is 8, what do you get out? Now look on your input. So again,
Okay.
yeah.
9.
Yeah,
Okay.
yeah, that's it. Check out those other two while I'm
Okay.
walking around. Sorry, oh sorry, I kicked
No,
over
it's
something.
okay.
Okay, good. Kick somebody's lunch over, jeez. I think, yeah, I think. What were we doing? Which one? I can't even remember. Yes, I know the first one. Yes, this looks good. This looks, oh, and then you just kept cruising.
Yeah.
Okay, yeah, I
Sorry.
think it looks pretty solid. How we doing?
I think I did it wrong.
You think you did it wrong?
Yeah.
Okay, let's go 5. So, let's take a look. So, first thing I do is I find g of 8. So, okay, here's the inputs. And so, if x is 8, g of 8 is 4. So, watch, I'm going to write this. See this? G of 8.
Mhm.
That just stands for this
Okay.
number here. So, the first thing I'm going to do is write this as f of 4.
Mhm.
Now, what's f of 4? So now I'm done with the g part. If I feed f of 4, what do I get out? Here's the output for f. Yeah. So the final answer is just 4. Yeah?
Yeah.
Does this sound okay? Let's do this one together.
Okay.
So what's g of 5? If I feed a 5 into g, what do I get out?
Go here.
So look at, here's your inputs here.
Oh wait. Oh,
Yeah.
Here.
Yes.
And then
Solid.
8.
So 8. So g of 5 is 8.
Mhm.
Let me write that on here so you kind of can see that. This thing right here, that's g of 5.
Okay.
Now, that's an 8. So we go here and just step by step watch this. Here, help yourself if you write this. G of 5 just means 8. Now, what's f of 8? Solid. 9. That's how you do it.
Okay.
So you kind of wind your way through the table.
Mhm.
Does that make sense?
Yeah.
Give those
Thank you.
last couple, you bet. Give those last couple a shot. Can I leave a pen somewhere?
Here.
Thank you. Awesome. Thanks. Cool. So I'm gonna walk through this. G of 8. So these are my inputs for the functions. Keep spelling input wrong. So G of 8 is this number right here. See, that's G of 8. This is G of 7. This is G of 0 up here. Input corresponding output. But we don't need any of those. We just need to know what is G of 8. It's the number 4. So I replace G of 8 with the number 4. And then I have to find, okay, if I feed a 4 into F, what do I get out? And I get back out 4. So this is F of 4. Even though it is equal to 4, it's also F of 4. So that's 4. Now G of 5 says start with the 5. Where does that take you? That takes you to, let's see, so G of 5 is 8. So G of 5 is 8. So this is F of 8. And then F of 8 is 9. I kind of worked through those with some folks, but now we've got them in the reverse order. Now I first feed into F, then into G. So 5, if I feed that into F, I get out a 0. This is F of 5 right here. It's just shorthand for 0. And G of 0, now I'm using this right column and the leftmost column. If I input a 0, I get out a, is that a 9 again? Yeah, so, okay, cool. And then finally, we've got F of 3. So F of 3 means first plug in 3, figure out what that is. So that's 8. This is F of 3 right here. So it's G of 8. And G of 8 is possibly yawn-worthy, but it's a 4. So my friends, I just want to give you a few minutes I'm going to stop talking about this stuff today. If we could maybe just spend a few minutes working on the homework, getting into it. That's what some folks are doing. If you're done with the homework, let me know, I'll give you more. It seems clear to me that we want to watch some of those videos for sure. So if you were having trouble with this, please, please, please watch the videos that are embedded in the text. Now is the time to learn this stuff before it gets heavy. And I'm here to consult. On Wednesday, we will talk a little more and work together.
This isn't meant to sound like a bad way, but is 1.2 and 1.3's homework meant to be doing the same day?
Yes.
Okay.
Yeah, it's cool. No, it's good. That wasn't a bad way. I was like, God, what is he gonna say? Like, this isn't bad, but your hair is terrible.
Yeah.
That's what I was waiting for. So no, Mace, you're good. We should hopefully ideally we'll have most of that started by class on Wednesday. And if we need more time, if it's looking like I need to push one out, I will absolutely do that.
Yeah, I didn't think I was really concerned much about the time. I was just making sure that
No, that's good. I appreciate it. That's a business question. Good stuff. What sport are you? Soccer. Cool. So I know they give you those sheets of absences, but you don't need to give me that because I'll just lose it.
Okay.
Just let me know in advance if you got a miss,
Okay.
and we'll figure it out.
I'm on season right now, so it
Oh,
should be done.
perfect. Okay,
Yeah.
awesome. Great. I'm just going to shut down the video, but I'm going to stay here and consult.